Hello again. Here we are on page 5 of Unit 4, Section 1, still talking about quadratics. So this is page 5. We have the vertex form where A is the leading coefficient. H is going to tell you whether or not the parabola goes to the right or to the left. And K is going to tell you if the parabola goes up or down. So A is the leading coefficient, same as the standard form. The vertex of the parabola is always going to be h and k, just like what we just did for absolute value. Is the same idea. So the equation for the axis of symmetry is a vertical line, so it's always going to be x equals. Just, if you don't give me that, if you just give me h, that's not right. You need the x equals because it's a line. If a is greater than 0, then k is the minimum value, because think about what the parabola would look like. It would look like this. The minimum value is where the vertex is down there. Now, when a is less than 0, your parabola would look like this. So it has the maximum value right there for k. And we're looking at the y value of the vertex. That's why we're talking about k. Minimum, maximum, right there. For the parent function, the vertex is at 0, 0, and it is a minimum because this is the parent function. This is the standard form. This is the original one. And the axis of symmetry is right there at x equals 0. This is the axis of symmetry right there. The axis of symmetry is a straight line, up and down, vertical, okay? That cuts the parabola in half. So it's always symmetric. For the parent function, it's always going to be at x equals 0. Always there, okay? AOS is axis of symmetry. Okay, now, page 6, we're going to bring back some things from Unit 1 when we're talking about increasing and decreasing interval. So an increase, when we're talking about increasing, it goes up. So it goes up in the parabola right there from 0 toward positive infinity. And that we're looking at the x values, okay? Not the y. But look at the behavior of this parabola, how it's going up right there. So it increases right there, starting at 0, going toward positive infinity. And it's decreasing all the way from negative infinity over here, all the way up to 0. And if it's an upside down parabola, it's increasing from negative infinity all the way up to 0 right there, and it starts to decrease right there at 0 and going toward positive infinity right there. Increase goes up, decrease goes down. Okay. Some Vertel form examples right here. I tried to color code it for you to make it easier to follow. So remember that we have y equals ax minus h squared plus k. So a is that number right there, right? The number in front. So a, h, and k. I also labeled them right here, color-coded, very pretty. So the vertex, we know it's h and k. So h is 4, k is 2. And it's going to look like a smiley face because a is positive. Oh, I'm jumping the gun over here. Axis of symmetry, x equals 4, because it's always going to be x equals h from the previous page, right there. So h right there is 4, so x equals 4. There's a minimum because the leading coefficient is positive, so your parabola is going to look like this, like a smiley face. So a value is 2, right there, and it opens up. That's what concavity means. I don't know why they want to come up with these fancy words, but just know it's asking you if it's open, it's going to open up or down. Another one, we have a, h, and k. A is the leading coefficient, 3. The vertex is h and k. Be careful with this, because even though it says plus 1 right there, remember the minus belongs to the formula, okay? That minus doesn't belong to 1. So that minus right there belongs to the formula. That's why it's -1, -7. The axis of symmetry is the h value. So, and it's because it's a line, you have to write the x equals. You have to. Minimum, because it opens up right there. And you will have a separate video for page 7.